Alright, welcome to another video for chemistry. In this chemistry we will continue precipitation reactions. This is part 2. So these are the key words that we're going to be looking at in this video: molecular equation, ionic equation, spectator ions, and net ionic equation. And we're going to be looking and using our solubility chart as we did in part 1. Okay, so let's look at our first equation, one that we've already seen in part 1, but we're going to look at it under a different scope and get a closer, much more exact, detailed look at what is happening in this equation. Okay, so this is what we call a chemical equation. Okay, it's balanced out and it shows all the different states of each species. So here you'll notice that I have lead nitrate and it's aqueous, potassium iodide, aqueous, and then I have my products here with the lead 2 iodide solid and potassium nitrate as an aqueous solution. So I have all the details. Okay, so this is also called a molecular equation, but there's a problem with this equation. This is not entirely accurate. It's not giving me a full picture of what is really happening in these solutions. They're not describing what is actually happening. The ionic compounds dissolve in water. They actually break apart. They're not together. So I might get the impression, if I look at, for example, lead nitrate, I might get the impression that because this equation is writing them together, that they're actually combined together in the solution. But in fact, they are not. They're floating freely apart from each other. So a more realistic equation would show the dissolved ions as separate. So let me show you what I'm talking about. So if I look at lead nitrate, for example, what's actually happening in the aqueous solution is that lead aqueous is floating and separate from nitrate aqueous. Okay, they're actually floating separately. Likewise with my other reactants, I have potassium aqueous floating freely and separate from iodine aqueous. And then on my product side, now this one's a little different because lead and iodine actually do combine together and they form a solid. So this in fact is accurate, okay, because they are combined. But my other product, they're still in an aqueous state, so they don't actually combine together. They float around, they bump into each other millions of times per second, but no reaction occurs, they don't combine, there's no match. All right? So this is what we call an ionic equation. An ionic equation is a more true equation showing which elements or which species, which atoms or molecules are actually reacting with one another. Okay? Now this is a little bit more elongated, of course, but it is more detailed and it is more accurate than my molecular equation. Okay, so let's discuss further now. This equation still doesn't show an entirely accurate picture of what's happening. Okay, so we want a net equation that will show the species that actually take part in the reaction, right? All right, so for example, I have here lead, and if I notice, I'll notice that lead is in an aqueous state. And then I go over to my product side and lead is now in a solid state. So there has been a change in state from aqueous, from an ion, to a solid molecule or a precipitate. And then I notice in my other reactant here, I go from being an aqueous state to it remains in an aqueous state. Okay, so there's no change in state for that particular species. Now, let's look at, oh, sorry, let me back up a little bit. So the fact that there is no reaction here, that it does not take part in the reaction, this is what I call a spectator ion, one of my key vocabulary words, okay? Think of the word spectator. If you're at a basketball game or at a football game, who are the spectators in this scenario? It's the people who are in the stands watching the game and cheering on and yelling. Now they're sitting back, they're sitting and watching, but they're not actually on the floor playing the game, so they're spectators. So in this case, in this particular chemistry game, nitrate, it goes from being aqueous and remaining aqueous. It does not take part in the game. It does not take part in the reaction, so it is a spectator ion. So I can cross those out because these two are not involved in the reaction. Now, if I look at potassium, I go from aqueous to aqueous. Again, no change in state, so these are spectator ions. So I can also mark those off because these are not taking part in the reaction. And then look at iodine. Iodine goes from being aqueous on the reactant side to a solid on the product side, and it combines with lead. So this is a change in state, so this is a reactant. Okay, so we've identified the ions that react from those that do not react, from the spectator ions. So now I can make a new equation. Okay, I can complete the equation, and my new equation will have lead aqueous plus iodine aqueous making a product, reacting and making a product of lead 2 iodide solid, or a precipitate. This new equation is called my net ionic equation. Net meaning what I'm left over. Okay, these net ionic equations, they only show species or ions that actually take part in the reaction. Okay, so hopefully this gives you an idea and helping you differentiate the different types of equations that we have. We have molecular equations, ionic equations, and then a net ionic equation. Let me give you another example. Let's look at another equation here. Okay, barium chloride with sodium sulfate, and then there's some kind of reaction, or we mix them together, and we end up with barium sulfate solid and sodium chloride aqueous. All right, so let's dissect this equation. Okay, so the molecular equation, right? It's balanced out. I have my states, so I'm good to go. I want to do an ionic equation that will more accurately depict what is happening in this scenario. So if I look at my product side, my reactant side, and I notice that barium chloride is in an aqueous state. That tells me that it's an aqueous state. That means they're separated, they're floating around, they have not combined together, so they are both separate, and so I would put a plus sign in between both of them. And I actually put the charges too, okay? Just to give you even more detail than even the previous scenario I gave you. So now I look at my other reactant, and I notice that they are also in an aqueous state, so they're not combined, right? And now I will take a look at my product side, and I notice that barium sulfate is in a solid state, so they do stay together because they are actually combined in the product side. And then of course sodium chloride, aqueous state, they are not combined together. So this is my full ionic equation. This more accurately depicts what the species or what the elements, okay, or compounds are doing in the solution. They're separate, they're not together, except for barium sulfate, which is a solid on the product side. So this is my ionic equation. But now my net ionic equation, if we remember, net ionic equation gives me the species that are actually involved in the reaction. So let's go one by one. Looking at my reactant side, let's look at barium. Let's first find our spectator ions. Barium. Barium goes from aqueous to solid. Alright, so you know that there's a change in state. So you know, let me back up. So you know that there's a change in state. So you know that this is involved in a reaction. Alright, now let's go down the line and look at chlorine. Chlorine goes from aqueous, and on the product side, it is still aqueous. So that means it's a spectator ion. It is not involved in this reaction. I can cross those out. Next down the line is sodium. Sodium on the reactant side is an aqueous state. Sodium on product side is in an aqueous state, so that is a spectator ion, not involved in the reaction. Sulfate. Sulfate on the reactant side is aqueous. Product side, it is a solid. So I have a change in state. So that means it is part of the reaction. Now this will now help me write my new net equation. So if I looked on my reactant side, which are the two species that change state? Barium and sulfate, right? And then I have a reaction that occurs, and then on my product side, the only species that changes state from the reactant to product is barium sulfate, and that is my precipitate, that is my solid, okay? And that's my net equation. So I have a molecular equation, then I have a more detailed ionic equation, and then I have my net equation, which gives me all the different species or atoms or compounds that are involved that are actually involved in a reaction. All the other ones are not involved in a reaction. Nothing happens when they combine or when they bump into other elements or compounds in their solutions. All right, well that concludes our precipitation reactions, part 2. Good luck in your studying.